Hello. Uh, in this lecture, I will explain temporary send data. They run this routing algorithm, find out the route, and in case of link failure, they maintain the route as well. So the basic task done using this routing algorithm are create route in case if there is no route is available for destination, erasing route. It will also erase invalid route and route maintenance if there is any kind of link failure. So because of those link failure, route has to be updated, so that updation part also done by Tora. So we will see one by one each of these steps. So how this temporary order routing algorithm works, it assign every node a height, and this height is not a single number. Actually, this is a 5 attribute tuple. So first tuple, tau, this is the actually these first three information is used in case if there is any link failure. Whenever there is a link failure, route has to be updated, and in that case these three information has to be used. Otherwise only these two information is in use. So the meaning of the first attribute is tau. This is the time when a link is broken. So this is the logical attribute. Actually in advance we don't know this thing. So whenever a link is broken, the affected node will set the time at which that link is broken, set its own id because that node is sending that information, and r, this is actually a reflection bit. We will see later what is the use of this attribute. And this one, these two are known as offset. I, this is the id of that node, and this number actually used to order the node, which like if you want to send from A to C, how the data transmission has to be done, like A to B to C. So this number will be like C will be 1, B will be 2, A will be 3. So you can say this one is the hop count as well, like in order to reach a node how many hop we have to go through. So these are three we are this routing algorithm assumes that uh, every node in initially a node having actually the idea where is the destination is, so they set their height null. So how this null is represented here, so I is the node of the that node, id of the node, and these attribute actually represented as dash 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 dash. So this actually is a null height, it means it's not known. And in case of if you want to represent zero height, so in that case 0 0 0 and id. So destination, height of a destination is always 0 because destination is reachable from itself by 0 hop count. So each node other than destination maintain its height. So we can say in a temporary ordered routing algorithm, every node maintain a array of heights, and that array actually contain height of every neighbors. So this height information for every neighbor is stored in array. So how it works, whenever a node wants to know the path for destination, it create a query packet, and that query packet is kind of like, I don't know the route for destination, can anyone please provide me the route. So that packet is known as QRY or query packet. That packet contains a destination address, and that node will broadcast it. So A will send this one to its neighbors, neighbors again rebroadcast it, and that one again rebroadcast it. So destination will be what is the old reference number plus 1, so they will increase old reference number by 1. Node id, what is the id of that node itself, and this third one will be 0 which is a reflection, fourth one also 0, and last one node id of that node itself. So let's take an example. So now we are saying this link is gone. So after going if this link is gone, if we can see this node is not having any downstream link. Every link is coming to this D, but there is no link that is going from D. So this is the second case, and in this second case, if this scenario happen and link, so this scenario, the reason for this scenario was because link was broken. So this node will create a new reference level. How it will do it? It will add 1 in the old reference, which is 0, so it will make first attribute as 1. Now second attribute, what will be the second attribute? Second attribute will be the ID of this node itself, because this node is creating reference level. Third node will be 0 itself. Fourth node also will be 0, and fifth node will be ID of this node itself. So it will update its height to this one, 1D00D. So how we read it? 1 means this is a new reference, this node has created a new information, so this 1 represent actually this is a new information. D, second attribute to specify who created this information, so node D has created this information. Third bit, which is 0, this is a reflection bit. Fourth, this is the height. What is the height of this node? So we are saying the height of this node is 0, and what is the ID of this node, which is D. So D will set a new reference level. Now if we compare this height with height of B, D will be high node, same B will be considered high node, and downstream link will be high to low. So this link direction will be changed, and this will be the scenario, and the problem is solved. Now every node is having a downstream link. Every node can send data to F successfully. So now we will see the last case. What happen when a node become without any downstream link, and all because of a route maintenance process, and its neighbors having same reference level. So we will be taking one more example. We are saying this link become inactive. So when this link become inactive, node A is not having any downstream link. In this case, this was the second case. In this case, node A defined a new reference level with order number 0, ID, its own ID A. They will take reference number of highest node. So this reference number will be taken as it is for B and for E, and the fourth attribute will be 1 less than this one. So B and E will update their height by 2A 1 minus 1 and B. So this will be new height for B, and for similar for E as well, 2A 1 minus 1 E. Now if this height is compared with A, so B become a high node. So in that case, this direction is reversed. So now node A is not having any downstream link, and why this happened? Because of route maintenance process. So whenever this thing happen, these node compare their neighbors reference, and A will find out reference of B is 2A1, reference of E is 2A1. After updation it will be 2A1, and this will be minus 1, and it will be E. So both are having same reference. Now there is a difference. The previous case what we have seen for same reference reflect, that was only for 0 value, but here we are having 1. So in case if a node become without downstream link and all of its neighbor having same reference number but R value as 1, this node will deduct that there is a partition in network, and this one is known as detect. So whenever a node detects some kind of situation, they will reset their height, and they set their height to null, and they broadcast a clear packet to its neighbor. So A will find out, say that what I have send some information to network, and that network again reflected that information same to me. It means there is some partition, and A will reset its height to null, and same it will send those clear packet to B and E. They will also reset, and they forward this packet to D. D also reset. So this network, all of node will reset their height. In case if you have any doubt, you can post your question on this page. Thank you very much.